Today on Zero to Lit I would highly advise that you remove your headphones and turn down your volume because today's video contains a lot of loud and annoying sounds, and some of them aren't my voice. Anyway, quick introduction before I continue. I have a whole bunch of these little alarm buzzers that generate a constant tone that I got from my friend, and I have absolutely no practical use for these. So I figured I'll come up with an impractical use and figure out how to make my own little sonic blaster, like LRAD pistol. So let's take a look at the board, see what we have. We have our little piezoelectric transducer, basically a piezoelectric crystal speaker. We have 9-volt input, AC input from like a wall adapter, reverse bias protection, Schottky diode right there, little capacitor for filtering the ripple off an AC power supply input. We have a step-up transformer. The primary is a center tapped. Says gives us two sides that are about 2 ohms apiece, so 4 ohms in total, and our secondary is 20 and 20, or 40 ohms in total, which gives us a transformer that's a step up about 10 times in voltage. Let's see what else we have here. A couple of resistors right here. We have a little hex inverter, so there's 6 inverters inside of this, and each of those are triple diode protected because it's fancy. A couple of little capacitors here. Let's see what we have. We have 180 nanofarad, picofarad, 180 picofarad, and what do we have over here? 100 picofarad. Another cap. Don't know what that's there for exactly. A couple other resistors there. That's about it. So very simple board. And I'll throw up a diagram of this later on in the video so you can make your own. But yeah, I figured I have a bunch of these. Alright, I may as well put them to use. Oh, those aside. In the thumbnail, you saw this. And this turned out pretty well. So I have 2 of those boards stacked on top. I have 2 transducers here in the front. I've hidden the transformers in this front section here. I have my batteries here. These are 2 E-hookah batteries that are A in series, giving me 8.4 volts when fully charged. That's all black TV plastic here, some lighting tubes that I use, little switch, and a little trigger mechanism. Anyway, so what does this do? Well, it makes sound, but there's a couple of modifications that make it extra annoying. So with an LRAD device or a sonic disruptor of sorts, you don't want to have just one frequency. You want to have multiple frequencies, and this way you have both the constructive and destructive interference coming out of the front. But that way, too, you can also get a wider coverage because, of course, different geometries of different rooms and areas will affect the way the frequencies bounce differently. So you want multiple frequencies. And I did a small modification to give me 2 different frequencies. On one of the boards, I added an extra resistor, and that changes the oscillation speed of this little resistor capacitor oscillator section here. I have my sneaking suspicion that there's actually a higher frequency, a carrier frequency, and then another oscillator circuit that generates the output tone. So for example, we have about 3.5 kilohertz coming out of here, but there might be a higher waveform on top of that. I'm not sure, but I can scope that out later to find out. So, how does this work? Well, it works pretty well. So I'm going to cover the 2 holes up with my fingers like this. We can hear what it sounds like, and just because of the way the circuit works, it'll start at a higher frequency and go down just a little bit and stabilize. So expect that. I think it's kind of cool. Alright, so now let's hear what one of these sounds like on their own. Yeah, it's very annoying. And this other one here. So you can see that that one is a slightly higher frequency. Well, because we have 2 frequencies, and we have the constructive and destructive interference, when they are both together, they're even more annoying. So take a listen at this. That is very annoying. But it's not what we're building in this video. Sorry for the spoof thumbnail, but it's to your advantage. So take a look at this. Oh yeah. That is going to be very annoying. Now, I've already got a start on this, and I've done a bunch of fungineering, and I would like to continue that. So let's get right into it. At this point, I pretty much have all the pieces made to put my sonic blaster together, and I just need to wire it. So let's get started with that. Here's the first section I need to finish off. So I have these plates that sit on here, and I have all my transformers. So I need to put 7 transformers in that plate. So I'll be gluing these down, and it's important how you glue your transformers, especially in a situation like this, and you'll see this in a lot of older radios too. But you do not want to have them side by side like this, because then they'll couple together magnetically and start to sympathetically oscillate. So you want to glue your transformers, if they're close together, in odd geometries, so that way they can't magnetically couple. You want to have it at a 90-degree offset to the transformers. So that's what I'll be doing. I got to figure out the geometry of which I want to lay my transformers out, and then glue them down. And my geometry will probably be something along the lines of this, just to make sure that I don't have any issues with that. So go ahead and lay that out. That needs to go that way. Nope. Put that. Yeah, we'll put that way. Nope, probably something like this, in a little hexagon arrangement. And then I need to, of course, wire them up to the piezo actuator stack in the front, the output. So let's go ahead and get that organized. I have to glue these transformers down in that arrangement, and then I can start with wiring. So it's time for the hot glue gun. Alrighty, this project has gone wrong. Should be gluing them. Yep, I screwed up. Off. I need to put it like that. Yeah. Now that I have my transformer assembly all put together, I can now start to attach the high sides of the transformer to the piezoelectric transducers in my array, starting with the center one. So I have this wire right here, and I have an inner connection and an outer connection. The outer connection is going to go to this tab on all the piezo drivers, and then this one is going to connect to these 2 inner tabs here. So let's go ahead and do that, and then get this plate mounted on the piezo assembly. And then from there, I can wire up the 6 on the outside pretty easily. So, with the help of the trusty soldering iron, we'll get to work. Alright, with that done, let's go ahead and mount it. Oh, come on. You can do it. Wrong way. Alright. Perfect. Look at that. Okay, we're going to need some other parts. Nice. Nice. Very nice. Go ahead and put the other ones in while I'm here. That's not going as well as I wanted it to, hey? Nothing is easy. Ah! I have only myself to blame. Those little homemade standoffs were a bit of a struggle, but now it's time to start wiring, so let's go ahead and do that. Alright, now that all the secondaries of the transformers are wired to the piezoelectric transducers, now I gotta wire up all the primaries of the transformers, and those will get 2 more wires, so I've got a bunch of wires here, so time to start doing that now. Yay! At this point, I have the entire step-up transformer assembly all done and connected to the piezoelectric driver array. So that's all good to go. I checked for shorts and there's no shorts. We're in the clear to continue on. To do that, we're going to take a look at this piece of plastic right here. And that will attach onto the top just like so. And then the driver boards are going to stack up on top of here. So here I have my stack of 7 drivers. And that turned out really well. Looks like something you find in a Fallout game, but I'm okay with that. So that'll actually end up attaching like this. And I made a couple pieces of metal, and that'll also be part of the frame. So here I have this piece, and that'll attach there just like that. And I made a couple of these brackets here too, which have their own placement. So let me see. Yeah, that one will end up going over here. And then I have another one that'll end up going over here. And so on and so forth. So we have a completed frame. Actually, those boards go sideways. But you get the point. So I'm going to start putting that frame together and getting all the pieces mounted. So take that off for the time being. Let's start with the 2 side pieces, which will be these 2. All right. Screws. Where did I put my screws? There we go. There's one. Go ahead and drop that in just like that. And then tools. I am underprepared for this task. Alright, we'll put that one there. And we'll put that one here. Okay. And now we go hunting for appropriate screws. Very good. All right, so those will fit in just like that. And then that will go in just like that. So yeah, that works very well. So what I'm going to do at this point, I'm going to cut a piece of foam to go between here and the boards. So that way they hold in a little bit better. And I have this back piece now that I can screw into place. So that's all marked except for this bottom hole. And that'll all screw together and hold the boards into place. After that, we can go ahead and work on attaching the handle, which sneaks in just like that. So it's coming together real quickly. Well, let's go ahead. I'm going to cut that piece of foam out, do that hole, and then I get the stack in here and start soldering the primary sides of the transformer to the board. That task has been now done, and we are moving forward. So, go ahead and put this first foam piece in like that. And I want to make sure that these connections are accessible because that's where the wires for the primary side of the transformer are going to be going. So each one of these are going to get 2 wires down the line. So I want that to be on, well, one of these sides on the top. So let's go ahead and flip it like that. That way all the wires can get routed over to this side and put together. Okay. Go ahead and get this piece all ready to be mounted. That's going to go ahead and connect like that. Perfect. Okay, cool. Hardware. Another thing I'm going to do is I'm going to attach the batteries, the battery holders. So one of them is going to go right there. And then one of them is going to go right here. And I have a call. I got to answer that. Where was I? Oh yes, that's right. Finishing this device. So go ahead and do that. Pop the battery holders on with a screw. So use these cursed little flathead screws. Come on, go in. There we go. Alright, so that'll drop in just like that right there. Into the hole. Perfect. Okay, and then you gotta add little nuts. Yes, I do use pliers with my nuts. Come on. Oh, you slipped sideways. You heathen.
Oh yeah.
More screws. Screws and fasteners. Oh yeah, these are the wrong ones. I need to get little washers, don't I? Perfecto. Kind of. I don't want to crack the plastic. That's my concern. Alright, we'll see how that goes. That looks pretty nice. Yeah. Loving how that's turning out, man. Loving how that's turning out. Alright, this could take longer than expected. Alright, now it's time to connect the primary side of the transformers up to the driver boards. So on each one of the driver boards, there are three little terminals on each one of the boards. So 1, 2, 3. And we're only going to be using 2 of them. So we got this terminal right here, and that connects to the NPN transistor. And then this one, which is a common connection with the high side of the transformer and the piezoelectric transducer. Now, each transformer now has 2 wires coming off of it. One wire, you'll notice that it's unmarked, and the other side is marked. The sides that aren't marked are going to end up going on the common end, and the sides that are marked are going to go and attach to where the PNP transistor is, or sorry, NPN transistor is on the circuit board. So let's go ahead and get those connected. Alright, so now I have done all the wiring, connecting the drivers up to the primary side of the transformers. And all I have to do now is work on connecting the wires for the battery compartments, and then attach the trigger assembly. Here's what that looks like. I have one of these mini push button switches from a microwave that I pulled out. I have that all wired up. And conveniently, I'm going to use the same hole in the switch, the location, as here, so that'll all lock in. There you go. That'll all lock in nice into place. Now that's going to be easy to do. Take these wires and jam them in. Get those folded down. And in just like that. Oh yes. As the engineers say, it's time for the marriage. So that's in. And screw. I know I have another screw here somewhere. There it is. Oh yeah, that feels dangerous. Love it. Absolutely. Alright, so now I have to take this and connect it to that point, which will put the battery packs in series. Once again, because it's 2 lithium-ion cells I'm planning to use, it's going to be 8.4 volts max charge. 2 batteries that are 4.2 volts apiece. I'm not going to use the AA size batteries. Unfortunately, I only have AAAs, but still should be able to test this once it's all put together. Kind of, I hope. Let's go ahead and do that. And I am going to use something to hold the tension in on the battery contacts like this, because when you heat up these, they tend to melt, and I don't want to push that through. I want to keep that plastic intact. So, little trick. You can also use a battery, but I try not to use batteries because they can get hot and you don't want your batteries to leak all over the place. just like that. Okay, and we're going to take these 3 wires. Now these 3 wires are actually negative. So I have 2 grouped here, 3 grouped in the middle, and 2 grouped here. And the reason why I have different groups is because eventually I might want to put in a little driver that'll do some more pulse width modulation, this type of stuff. So that way I can do more sweeping of different ranges and do more interesting sounds. But as for now, I don't have anything to do that. So I'm just going to keep these grouped together, a common negative, and put that where it needs to go, which is going to be right here. And in the future, if I do an update, I'll let you know. One of the other updates that I want to do actually is to put LEDs in here, so that way it'll produce light. I'm thinking orange LEDs would look real nice in there, but that's the idea for the future. We'll see what we get. Alright, and then the last thing to really do electrically, besides adding the resistors that change the tone, is to connect the trigger switch to the positive side where the batteries come in. So one side is going to get connected to the battery pack over here on the positive, and then the other side of the switch is going to get connected to this, which is the positive input to the stack of the driver boards. That should be pretty easy and pretty quick to do. I'll run this up and through. to my knowledge, it is electrically done and ready to go. Aside from doing the resistor modifications. So I'm going to go ahead and do that off camera. I'm going to put some batteries in here and we're going to see how annoying this thing really is. Oh, the power. Let's go ahead and test out this canary caller. I'm going to shoot it at that wall. The sound's going to come back and you should get a good idea of how loud this thing is for somebody on the receiving end of this. Let's flip it around. Oh, that was a mistake. Alright, now we're going to get a reading on how loud these sonic crystals are. So, tell me how loud this is.
94.
94, alright, another big one.
94.
Really?
Yep.
About the same, wow.
Try both.
Try resetting it.
Okay, go ahead.
Alright.
94.8.
Really? Alright, both of them.
Oh, hold on. 95.8.
That's crazy. I would expect this one to be much louder, but maybe mess around with the frequencies a little bit more and see if we can get more output.
Buddy!
That sure sounds a lot louder, though. I mean,
It does.
that sounds way louder. What's more fun than a sonic crystal? A sonic pistol with accessories. And one of our most popular is the loudener. So we're going to go ahead and see if this makes any improvement when capturing a measurement. Alright, you ready? Now we gained the dB!
81.
81,
81? Alright.
buddy.
88.
No, it does work. I'm gonna do beep.
87.
Do it one more time.
Alright.
About 83. 83.
These sonic pistols were an unexpected project, but I had a lot of fun making them. And if I choose to do modifications in the future, such as installing LEDs or increasing their annoyance factor, I may do a follow-up video on them in the future. With that said, I must once again bid you farewell, but before I do, I want to show you a clever use of some nice twinkling neons, and we're going to appreciate that like it's 1985. I hope you enjoyed the video, and as always, stay tuned for more.
Oh,
Wow.
I didn't get a reaction.
He's got headphones on, so.
Oh, he's got headphones on. Damn it.
Hello.
Oh, unbelievable.
Take a look at it.
Push the button there. A lot of boards.
Oh yeah.
Oh, yeah.
Push the button.
Ah, fuck! Ow!
Oh, wow.
Insane.
I know, right? You got headphones on.
You made your own LRAD, huh?
Oh yeah, absolutely. It's effective too, isn't it?
Yeah.